Welcome back, Math 2. I now would like to start talking about something called the simplest radical form, or otherwise known as simplified radical form, or sometimes you'll see it written as simply SRF. Now, what happens in simplified radical form, or simplest radical form, is I want to take an expression in the form the square root of a and rewrite it so that the number underneath the radical, or under the square root sign, is not divisible by a perfect square. And it's going to look something like r times the square root of s. But that is the exact same number as the square root of a, except I've broken it down into smaller pieces and simplified it. Now here's what I mean. Look at this first example, the square root of 75. I want to think about all of my perfect square numbers. I'm going to ask myself, what is a perfect square that I can multiply by another number and get 75? 4, no. 9, no. 16, no. 25, yes. So that's the square root of 25 times the square root of 3. Well, we know what the square root of 25 equals. That's just 5. And the square root of 3 doesn't combine with anything else, so we just leave that as the square root of 3. So 5 root 3 is my simplified or simplest radical form. Because if I look at that number 3, there is no perfect square that would divide evenly into 3. Let's think about another example. The square root of 600. Automatically, my brain says, hey, 600 is really 100 times 6. So I have the square root of 100 times the square root of 6. But the square root of 100, we know that that is the number 10. Square root of 6 does not simplify, so square root of 6. And that's my simplified radical form. Now, some people might say, but Miss Shana, I could say that root 6 is root 3 times root 2. And while that's true, neither one of those have a perfect whole number square root. So 3 and 2 are not perfect squares. So I wouldn't want to break down my 6 into those factors. Now let's look at one that might be a little trickier for us. The square root of 192. Well, darn. Well, the first thing I do is I go for my calculator. And I see, wow, maybe Miss Shin is tricking me. Maybe this is actually a perfect square. But I figure out that it's at a decimal when I punch it up. It's about 13.856. So I'm going to come up with two numbers whose product is 192. Let me try the number 4. I want to know, does 4 times anything equal 192? And why, yes, 48. So we know that the square root of 4 equals 2. So I really have 2 times the square root of 48. And some of us want to say, yay, we're done. I'm not, though. I still need to see if there's a way for me to break up the square root of 48 into a product where one of the factors is a perfect square. And so I start thinking about my numbers. 1, no, 4, yes, but that's, again, we're going to keep doing this over and over again. I'd like to get done a little quicker. Well, 16 times 3 equals 48. So I'm going to rewrite the square root of 48 as the square root of 16 times the square root of 3. And we know that the square root of 16 is 4. Now I have not changed my root 3, so it's still times root 3. And I'm still being multiplied by the number 2 out front from my previous simplification. So we have 2 times 4 times root 3. And we know that 2 times 4 equals 8. So 8 times the square root of 3 is my simplest radical form. Yes, there are shorter ways we could have gone to get there, but you don't have to get there as quick as everybody else. You just eventually want to get to the same place. That being said, guys, let's give it a try. Good luck, and let me know where you need help.